Bismillahirrahmanirrahim. Assalamu alaikum. I welcome you all to the new lecture of NS224 numerical analysis. This is Syed Ibrahim, your numerical analysis teacher. In today's lecture, I would like to discuss fixed point iterative method. The fixed point iterative method is also known as one point iteration or successive substitution. uh, to find the root of f of x is equal to 0, as we have discussed it before in the previous lectures, that through numerical methods we can find the approximate solution of those equations which cannot be solved through analytical equation, or there are no such a analytical methods for those equations. So we come towards the numerical methods and we solve it through numerical methods, and we find the approximate solution for that equation. So if we have an equation f of x is equal to 0, either if it is a transcendental equation or it is an algebraic equation, so we can find the root of those equations through that method as well. If we can solve these equations, the equation f of x is equal to 0, and we can reduce it to g of x is equal to x, then the fixed point, through fixed point iteration method, we can generate a scheme for for those equation, and finally we get the result. Uh, we solve g of x is equal to x by computing xi plus 1 is equal to g of x, and then we substitute different values for I. For I is equal to 1, 2, 3, 4, 5, 6, 7, 8, and so on. So for the initial guess, we will follow those steps which we have discussed in the previous lecture from the Newton-Robson method, because the Newton-Robson method is the modified form of fixed point iteration method. So in the same way as we have found x naught the initial guess for the Newton-Robson method, in the same way we will find x naught the initial guess for the fixed point iteration method. So, if we want to find the solution, the approximate solution of an equation through fixed point iteration method, then you need to follow these steps. In the first step, you need to find the x naught, the initial guess, which we have discussed in the previous lecture. So you can find x naught very easily, or it will be given. X naught will be given. The initial guess will be given to you. Then what you need to do, you need to decide g of x. That what should be the right scheme generating function. So how could we decide it? We will discuss it in the example. So you will decide g of x, the scheme generating function, the absolute value of the derivative of that function is less than 1. So if it is less than 1, g prime of x naught, and the absolute of g prime of x naught, if it is less than 1, then the scheme will converge, otherwise it will diverge. Then what you need to do, if g prime of x naught absolute is less than 1, then you will substitute xi plus 1 is equal to g of xi, and then you will proceed your scheme for I is equal to 0, 1, 2, 3, 4 for different value of I. You will get you will start for I is equal to 0, you will get the first iteration. For I is equal to 1, you will get the second iteration, and in the same way you will get x3, x4, x5, and as you increase your iteration, you will get closer and closer toward the exact solution of the function. Let us take an example to solve. After solving this equation through a fixed point iteration method, you will learn the complete procedure how to solve a transcendental or an algebraic equation through fixed point iteration method. So the main thing in fixed point iteration method is to decide the right system generating function. So as we have learned how to find x naught in the previous lectures in Newton-Raphson method, so or in bisection method. In bisection method, we have learned from the intermediate value theorem that if the function have different sign at the boundaries of an interval, then there must be at least one solution of the function in that interval if and only if the function is continuous in that interval. And then we decide the two guesses for bisection method, and in that two guesses we can decide one guess which is near to the root for Newton-Raphson method. In the same way we can find that initial guess x naught for the fixed point iteration method. So here I have taken f of x is equal to x square minus 2x minus 3, which we can easily solve this equation through the analytical method, through the quadratic equation, quadratic formula, which is quadratic equation. So we can solve it through quadratic formula as well as through factorization and through completing square. And the exact solution of these equation are minus 1 and 3. So the I have taken this equation to understand the complete way how the fixed point iteration method or other numerical method go toward the exit solution. As we increase the number of iteration, we will get closer and closer toward the exit root of these equations. So the exit roots of this equation is minus 1 and 3. If we are getting closer to minus 1 or 3, so it means that we are getting closer and closer toward the exit root. Otherwise, if we are going far away from the minus 3, the from 3 and minus 1, so it means the system is divergent. So if someone tell you to solve this equation for x, which is x square minus 2x minus 3, you can directly solve it for x through taking shifting these two terms to the right side, and after taking the square root you will get x is equal to under the root 2x plus 3. And if you solve these equation for x, then it may be your system generating function, and you can write it xi plus 1 is equal to g of xi is equal to under the root 2xi plus 3. The another student will tell you I can solve it for x in this way as well, by taking x common from these two terms and taking 3 to the right side. You will get x into x minus 2 is equal to 3, and by dividing both hand side by x minus 2 you will get x is equal to 3 divided by x minus 2. And we can write we can take x on one side in this way as well. So it may also be the system generating function, and we can write it xi plus 1 is equal to g of xi is equal to 3 divided by xi minus 2. And in the third, student will tell you that I can solve it in this way as well, by taking these term to this side. This will get positive by taking it to the another side. So 2x will be equal to x square minus 3, and by dividing both hand side by 2 you will get x is equal to x square minus 3 divided by 2. So it also may be the system generating function. I plus xi plus 1 is equal to g of xi is equal to xi square minus 3 divided by 2. So the student in case A who have found the system for his approximate solution xi plus 1 is equal to g of xi is equal to under the root 2 xi plus 3. If he start to find the approximate solution, then he will substitute for I is equal to 0. He will get the value of x1 is equal to under the root 2 x naught. By substituting I is equal to 0 in this scheme, you will get here I is equal to 0, so you will get x1. And by substituting I is equal to 0 in here, you will get under the root 2x naught plus 3, which is equal to, we know the value of x naught. By substituting the value of x naught, you will get under the root 2 into 4, which is 8, plus 3 under the root 11 is 3.31662. And for I is equal to 1, he will get his second iteration, and for I is equal to 2, he will get his third iteration, and for I is equal to 3, he will get his fourth iteration. In the same way, at 13th iteration, he get his approximate solution, which is very near to the exact solution 3 of the equation. The student who have found the system for the system generating function in case B for the approximate solution. So if he started for I is equal to 0, for I is equal to 0 in the first iteration, he will get 1.5. For I is equal to 1, he will get -6. For I is equal to 2, he will get minus 0.375, and so on. At 16th iteration, he will get another approximate root of the equation, which is also near to the another root of the equation. So the third student who have decided the system generating function xi plus 1 is equal to g of xi is equal to xi square minus 3 divided by 2. For the I is equal to 0, for the in the first iteration he will get 6.5. In the second iteration, for I is equal to 1, he will get 19.625, which is a very large value, which is very far away from the root of the function. And for I is equal to 3, he will get 191 point something value, which is 191.070. So for I is equal to 3 and so on, he will get greater and greater value, and the system will divert. It will never ever converge to the root of the function. So this scheme is not the right one scheme. This scheme is right one. We can get the solution of the approximate solution of the equation through this scheme, but it is a very time consuming. We get the approximate root after a very long procedure, and here we get the result very fastly. So this one is the best one. So how will we decide which one is the best system generating function, or how will we find this g of x which is fastly converging? So, to find the right system generating function, what you need to do, you need to solve the given equation for x. After solving the given equation for x, you need to differentiate it. And after differentiating, when you substitute your initial guess and take the absolute value of g prime of x naught, if it is less than 1, then the system generating function, which is x is equal to g of x, is the right one, and you will write xi plus 1 is equal to g of xi is equal to under the root 2 xi plus 3, and you will start your iteration in fixed point iteration method. What is in the case b? If in case B, if someone find the system generating function, that one, if he differentiate it as well, he will get g prime of x naught absolute less than 1, and he can get the approximate solution through this system as well. But in the third case, in case C, that one is case C. In case C, if he decided these one system generating a function, and if he differentiate it, after differentiating, when he substitute the value of x dot in the differential form of his suspected system generating function, he will get greater than one value. The absolute value of g prime of x naught must be greater than 1, so it will diverge. So he will go toward the another suspecting values of the system generating function. He will never proceed his equation after getting this result. If someone tell you to find the approximate solution of f of x is equal to x square minus 2x minus 3 using first fixed point iteration method, if the value of x naught is given, so well and good. Otherwise, you can find the value of x naught using the same concept as we have discussed in Newton-Raphson method. So first, what you need to do, you need to find the value of x. After finding the value of x, you need to suppose that x is the system generating function g of x, and after differentiating these suspected system generating function, you need to substitute the value of x naught, and after taking the absolute value, if the absolute value of g prime of x naught is less than 1, then the system generating function is the right one system. Otherwise, you need to go toward the another system generating functions. Or if the g prime of x naught is less than 1, you don't need to go to find the other suspected values for the system generating function. So if that one is the right one, so you will write xi plus 1 is equal to g of xi, which is equal to under the root 2 times xi plus 3. And for I is equal to 0, 1, 2, 3, you will start your iteration. To learn the coding for these system, how will we write coding for our system in the fixed point iteration method, which is similar to the Newton-Raphson method. Now, first you need to write your initial guess in your calculator, and after pressing equal button and press AC button, the calculator will assign your initial guess as its answer. And after assigning your initial guess as answer to your calculator, you will write your system generating function in calculator by replacing x by answer. How can we write it? We will write it 2 times answer plus 3. So after pressing once the equal button, you will get your first iteration, which is 3.31662. And after pressing equal button at the second time, you will get your second iteration. And after pressing equal button at third time, you will get your third iteration. And after pressing equal button at fourth time, you will get your fourth iteration. After equal button pressing equal button at fifth time, you will get your fifth iteration. And similarly, through this coding, you can get a very close value, or very close value to the exact root of the function after pressing the equal button at the sixth time. You will get the another root at time. You will get 3.004231 at 9 time. You will get your ninth root. At 10th time, you will get your 10th iteration, and at 11th time, at 12th time, and at 13th time, you will get that one result. So by calculator coding, it is very easy, but you need to program it according to your initial your system generating function. If my system generating function is other than that, so just you need to replace x by answer and write the same one in your calculator. And first of all, you need to write your initial guess, then you will press equal button, and after pressing equal button, the calculator will remember your initial guess as answer, and after pressing the AC button, you will write your system generating function in your calculator, and after pressing the equal button, you will get your first iteration, and by repeating your the pressing the equal button, you will get the third, fourth, fifth, sixth, and so on, and you will get the closure value. So it will be given to you that how much iteration you need to perform. So if you have learned this method, so try these equation. If you can solve these equations, so it means that you have learned it. So to find the initial guess for this equation, what you need to do, you need to press the move button and then press 7. You will get f of x is equal to, so I can write here my equation, which is x cubed. So I will write x cubed minus 4 times x square plus x minus 10. And then after pressing equal button, my calculator will ask me from where you want to start your you want to generate your table. So I would like to start my table from minus 5. My table will end at 5 and the step size will be 1. So at x is equal to minus 5, the function is minus 240. At x is equal to minus 4, the function is minus 142. At x is equal to minus 3, the function is negative, and so on. So at x is equal to 4, the function is negative, and at x is equal to 5, the function is positive. So x naught is x naught is equal to 4. So because the function have at x is equal to 4, the function have negative value and which is near to 0, and at x is equal to 5, the function have positive value, but it is far from 0 according to 4 minus 6, as minus 6 is very near as compared to 20 to 0. So here also in this equation x naught is equal to 4, and try to solve this equation. If you have any problem, you can contact me through my WhatsApp number, or you can write your questions through Google Classroom. I will answer you. So the conclusion is the fixed point iteration method is a very expensive method because we are performing all the steps. The main drawback of the Newton-Raphson method was the finding the derivative of the function. So also you need here, you need to find the derivative of the function, as well you need to perform another step for deciding the your system generating function. So this one is a very expensive method, and it have a lot of drawbacks as compared to the other methods. So the Newton-Raphson method is better one, and the Newton-Raphson method is the modified form of fixed point iteration method. It was necessary to discuss it. So it was fixed point iteration method. If you have any other question, you can ask me, and through fixed point iteration method we can find the approximate solution of transcendental and those transcendental and algebraic equation, which solution cannot be found through the analytical method. As well, we can find the approximate solution of those equations which can be solved through analytical method as well, as we have solved the example. So let us see you in next lecture. These three methods are also called the open method, the secant method, and the Newton-Raphson method. And fixed point iteration method is also called the open methods. And we will discuss the regular falsi method in the next lecture, and the bisection methods are called the bracket method. Why we call it bracket method, and why we call the Newton-Raphson method, and the secant method and fixed point iteration method, open method, we will discuss it in next lecture. So see you in next lecture. Thank you for watching this lecture. Assalamu alaikum.